Okay, it is practice test day. So hopefully you have worked through this whole thing and you have already checked your answers with the PDF that I provided, and then you're here watching this video just to kind of get clarification on some that you may have missed. So if you still have questions after this video, and again, don't watch the whole thing. If you got this whole first page right, then just go to page 2 in my video, fast forward through and just watch the ones that you missed. So let's talk about these. Oh, and what I was going to say is if you still have questions, I'll do a Zoom call again today, and you can get on there and double check with me. Okay, find the next 3 terms in each sequence. So figure out what's happening. On number 1, we should have realized, hey, we're adding 2 every time. So the next 3 are going to be 8, 10, and 12. On this one, what's happening every time? Well, I'm adding 7, adding 7, adding 7. So I would get 36, 43, and 50. Okay, what about on number 3? Oh, actually, you know what? Number 3 is a typo. I'll remember to tell you all that. Okay, so skip that one. Number 4, it says identify each sequence as geometric or arithmetic, write the rule for each sequence, and then find the next 3 terms. Okay, so on number 4, is it geometric or arithmetic? It is geometric. And the rule should be start with 750 and multiply by 0.1 repeatedly, okay? Or 1 over 10. If you're not sure, you start with the second number and do 75 divided by 750, it's 0.1. What's 7.5 divided by 75? 0.1. What's 0.75 divided by, divided by 7.5, 0.1. That's how you can figure it out if you're not sure. And then the next 3, 0.75 times 0.1 would be 0.075, 0.0075, and 0.00075. Again, 0.75 times 0.1, 0.075 times 0.1, 0.0075 times 0.1, whoops, I did divide, 0.00075. Okay, let's look at the next one. Looking for a different color. Here we go. Okay, what's happening on this one? It is geometric. And the rule is start with 3 and multiply by 2 repeatedly. Okay, and then the next 3 are 48, 96, and 192. Let me double check. 24 times 2, 48 times 2, 96 times 2, 192. Okay, let's come up here and look at number 6. What's happening every time? First of all, is it going up or down? It's going down by, if you're not sure, do 2.3 minus 2.8. The difference is negative 0.5, so that's what we're adding every time. So this would be arithmetic because we are adding, and we're going to say start with, oh gosh, sorry, I have like a new setup and it's bumpy. Start with 2.8 and add negative 0.5 repeatedly, right? So let's let 2.8 plus 0.5 negative, 2.3 plus negative 0.5, whoops, I did that wrong. So 2.8 plus negative 0.5, 2.3, plus negative 0.5, 1.8, plus negative 0.5, 1.3, plus negative 0.5, 0.8, plus negative 0.5, 0.3, plus, not times, negative 0.5, negative 0.2. Okay, then let's look at the next one. We have a third of a pizza, then a whole pizza, then 3 pizzas, then 9 pizzas. Okay, this is geometric, and the rule is start with 1/3 and multiply by 3 repeatedly. So 27 or 9 times 3 would be 27, times 3 is 81, times 3 is 243. Okay, number 8, 10.2, 12.2, 14.2. What's happening? We are adding 2. So our rule is going to be start with 10.2 and add 2 repeatedly. So that's going to give us 16.2, 18.2, and then 20.2. And then number 9, this one looks weird because we're going positive 5, negative 10, positive 20, negative 40. So that should tell you that you're multiplying by a negative. So it's geometric. And the rule is start with 5 and multiply by negative 2 repeatedly. Because remember, a negative times a negative is going to give us a positive. So 5 times negative 2 is negative 10. Negative 10 times negative 2 is positive 20. Okay, so then this would be 80, 160, 320, and let's look. It goes negative, positive, negative, positive. Okay, find the first 4 terms of the sequence represented by each expression. Okay, and then in parentheses, I'm telling you that n is 1, 2, 3, and 4. So 3 plus 2 times 1 is 5. 3 plus 2 times 2, 2 times 2 is 4, 4 plus 3 is 7. 3 plus 2 times 3, 2 times 3 is 6. 6 plus 3 is 9. You guys can probably see what's happening here. 2 times 4 is 8. 8 plus 3 is 11. We always have to use PEMDAS, right? So we have to do this multiplication first. Just like this one. 3 times 1 is 3. 3 plus 2 is 5. 3 times 2 is 6. 6 plus 2 is 8. 3 times 3 is 9. 9 plus 2 is 11. 3 times 4 is 12. 12 plus 2 is 14. Okay, I'm going to go ahead and write this first one out. So this is 1 times 1 plus 10. So that's essentially 1 times 11, which is 11. 2 times 2 plus 10. So that's 2 times 12, which is 24. 3 times 3 plus 10. That's 3 times 13, which is 39. 4 times 4 plus 10 is 4 times 14, which is 56. Okay, and use a calculator, absolutely fine, but we always have to use PEMDAS. Okay, next page. It says use the function rule f of x equals 2x plus 3 and find each output. Okay, so 2 times 0 plus 3, because we're figuring it out for f is 0. So 2 times 0 is 0, 0 plus 3 is 3. Well, what if x is 5.5? 2 times 5.5 is 11, 11 plus 3 is 14. Well, what if it's negative 2? 2 times negative 2 is negative 4, plus 3 is negative 1. Well, what if f is 7? 2 times 7 is 14. 14 plus 3 is 17. So we're just plugging in those numbers. Okay, in the table, it's giving us the input and then wanting us to find the output. And it's 4 times whatever x is. So 4 times 5 is 20. 4 times 7 is 28. 4 times 9 is 36. 4 times 11 is 44. Okay, we're doing the same thing over here. Okay, so if I put a 0 in, 5 times 0 is 0, 20 minus 0 is 20. Well, what if I put a 1 in here? 5 times 1 is 5, 20 minus 5 is 15. Okay, so let's kind of look at the pattern that's happening here. It's going minus 5, minus 5, minus 5, right? And then what do we think is going to happen here? We're adding 1, adding 1, adding 1. Okay? Number 19. We're going to start every single time. Here, I'll do a little. You're going to start at the y-intercept and then follow slope, which is always rise over run. Okay, so on number 19, the y-intercept is 5. 1, 2, 3, 4, 5. My slope is -2, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, and then I'm going to connect them. Okay, number 20, my y-intercept is -1. So I'm starting at -1, then I'm going to rise 2, run 3. It's giving you the directions, rise over run, rise 2, run 3, rise 2, run 3. Over here, my y-intercept is -2. My slope is -3 over 5. So that means we're not going up, we're going down 3 and over 5. Whoops, sorry. Okay, or up 3 and over -5. But either way, that's what our graph should look like. Okay, sorry, shuffling papers around. Okay, and then the next one down here, number 21. Again, we're starting at the y-intercept, +5. 1, 2, 3, 4, 5. This is my y-axis. My slope is -1 over 2. Down 1 over 2. Down 1 over 2. I connect them. Here I'm starting on my y-intercept, which is -3, and my slope is rise 2, run 5. Okay, here I don't have a y-intercept. It's like, or it's not like, it is 0. And then my slope is 2. How can I write 2 as a fraction? I put it over 1. Rise 2, run 1. Rise 2, run 1. Okay, should all be review. Okay, start at the y-intercept, follow the slope. Let's look at this next page. It says Mrs. Savin receives a base salary of $1,000 plus a commission of $1,500 on each car that she sells. Write a function rule that shows how her total pay depends on how many cars she sells. So her pay depends on how many cars. And she makes $1,000, right? No matter what, even if she sells 0 cars. Then she makes $1,500 times every car that she sells. So this would be how we would figure out her salary. What if she sold 0 cars? She would make no commission, but she would still get her $1,000. So the next part says, what if she sells or evaluated for X is 15? Okay, that's the same thing as C is 15, whatever. It doesn't matter if I had made this P of X. So she makes her $1,000 plus $1,500 times 15 cars. So let's figure out what her commission would be. So she makes $1,500 times 15 cars. That's $22,500 plus her $1,000 base. So she makes $23,500. Okay, the next one says, Will paid $8 to join the monthly movie club and now gets movies for $3 per ticket. So write a function rule to show how his monthly bill depends on how many movie tickets he buys. So his bill depends on how many tickets, and he pays $8 to join the club, and then his movies are $3 a ticket. So what if he bought 11 movie tickets this month? So he would pay $8 plus $3 times 11 tickets. So 3 times 11 is 33, plus he had to pay $8 to be in the club, so he would have to pay $41. Okay, on to 24. So this one, let me draw a little thing over here. It's y equals blank x plus blank. Okay, and this first blank is going to be change. Let me see if I can write it in here. It's really little. Change in y over change, I should have done it a different color, in x. And this is what y equals when x equals 0. Okay, it was written big on notes we took, the last set of notes we took. Okay, so y equals the change in y. What's happening here? We're going down 3. And what's my change in x? It's going -2 to 0 is +2, +2, +2. Okay, and then when x was 0, what was y? +2. Okay, look at 25. What's the change in y? It's going up 1, up 1, up 1. What's the change in x? Up 3, up 3, up 3. So change in y is 1, change in x is 3. Okay, y equals 1/3 x. When x was 0, what was y? 0. So I don't even have to write +0. It's just y equals 1/3 x. Okay, number 26, y equals, okay, what would be the change in y? If it's -8, -13, -18, that's going down 5 every time. And what's happening to my x? That's going up 5 every time. So change in y over change in x, what would be -5 over 5? -1. And then when x was 0, what was y? -8. Okay, and then on 27, y equals change in y. This is going up 2 every time over change in x. This is going down 2. What's 2 over -2? -1x. Then when x was 0, what was y? 11. Okay, and then here, use the slope and y-intercept to write the equation for each graph. So y equals mx plus b. So what goes in front of x is always the slope. Going from left to right, slope dude is going down 1, 2, 3 over 2. So -3 over 2x, and where does it cross the y-axis? At +2. Okay, here, slope dude from left to right, he's going up 1 over 3. Y equals 1/3 x, and then it's crossing at 0. So +0. And then this one, y equals, slope dude going left to right is going down 3 over 1. So -3, and then it's crossing at 0. So I don't even have to write +0. Okay, and then this last one, slope dude left to right is rising 2, running 1, 2, 3, 4, 5. So 2 over 5x, and then it's crossing at 0. Okay, it's going to be super, super important. You have to do y equals and then the x, otherwise you didn't write a linear equation. Okay, last page, non-linear functions. Okay, so let's look at 31. So the first one, it says it's x squared, but then it's negative. So if I square -3, that's +9, but then I'm making it negative. So -9 plus 1 is -8. You don't have to fill in all this ordered pair stuff. But I would get -3, -8. Okay, then this I would get -2 squared is 4, but then I'm making it negative. -4 plus 1 is -3. So I have the ordered pair -2, -3. Well, what if I square 1 and make it negative? -1 plus 1 is 0. -1, 0. If I square 0, it's just 0. Plus 1 is 1, 0, 1. Okay, then here if I square 1 and make it negative, -1 plus 1 is 0. And then -4 plus 1 is -3. And then 3 squared would be 9, and then I'm making it negative. That would give me 3, -8. Okay, so I'm going to graph it. -3, -1, 2, 3, 4, 5, 6, 7, 8. -2, -1, 2, 3. -1, 0. And then 0, 1. And then it mirrors on this side. I'm going to connect it with my curved line to make a parabola. Okay, and then the last one is an absolute value, so I know it's going to make a V shape. The absolute value of -3 is 3. 3 minus 5 is -2. 2 minus 5 is negative 3. 1 minus 5 is negative 4. 0 minus 5 is negative 5. 1 minus 5 is negative 4. 2 minus 5 is negative 3. 3 minus 5 is negative 2. And now I'm going to graph these. So I have negative 3, negative 2, negative 2, negative 3, negative 1, negative 4, 0, negative 5. And then it mirrors on the other side. Okay, so if you've watched this, you still have questions, you need more help, there will be a Zoom call today. I'll post the link on our Google Classroom and you guys can join. Make sure you have your stuff with you, ready to ask questions. And that's it. Tomorrow your test will be pretty much just like this. I'm just trying to figure out if I'm going to do, Google form or print and scan and all that.